Welcome back to page 7, number 46. What is the equation of the line with a slope of 3 and passing through point 1, negative 3 in slope-intercept form and point slope form? Okay, what is the equation of the line? So they want you as a final answer to provide them an equation. Now, they want the equation in slope-intercept, which is y equals mx plus b, and in point slope, which is y minus y1 equals x, equals m times x minus x1. So they want it in both forms. Now the information that they give you is the slope of 3, and a point on your line. So since we have the slope, we already have an important part done. Now, just like we've done before, we're going to start by finding the point slope form of the line and then convert it into slope intercept. So let's go ahead and plug in. We are going to have, for point slope form, since we already have the slope, all we need to do is plug in the point. We're going to do y minus y1 is negative 3 equals our slope of 3 times x minus, and x1 is 1. To simplify point slope form a little bit, we have to make sure we take care of any double negatives. So this is y plus 3 equals 3 times x minus 1. And we're done for the first part. We have it now in point slope form. That's this right here. Now, to convert it into slope-intercept form, we're going to go ahead and we're going to expand this. We're going to distribute the 3, and then we're going to bring over the plus 3 next to the y to the other side. So let's start by distributing the 3. So it's going to be y plus 3 equals 3x. 3 times negative 1 is negative 3. And this is almost done. Last step, we have to subtract the 3 from both sides so that it's y alone. And now it's y equals 3x minus 6. Technical difficulty. Give me 1 second. Okay. So now we have slope-intercept form here. So this is the same line in 2 different forms. Point slope, which is what we start with. As soon as we have slope, we can plug into point slope. And then slope intercept, which we get by expanding point slope form. All right, let's go on to 47. 47. Which is the equation of the line that passes through the points negative 2, 7 and 6, negative 5 in slope-intercept form? So what is the equation of the line? And they want it just in slope-intercept form. So y equals mx plus b. Now the way that we're going to get the equation of a line in slope-intercept form is we're going to use point slope form. Before we can use point slope form, you have to figure out the slope. So before we could do y minus y1 equals m times x minus x1, we have to first figure out that slope. So to figure out the slope, we're going to use the 2 points. I'm going to use the slope formula. So this is my x1, y1, x2, y2. So m equals negative 5, or y2, minus y1 is 7, over x2, which is 6, minus x1, which is negative 2. And now let's simplify. Negative 5 minus 7, you're going to get negative 12. 6 plus 2, double negative becomes a positive. 6 plus 2 is 8. And now, last step, we're going to simplify. Divide the top and bottom by the greatest common factor, which in this case is going to be 4. 12 and 8 can be divided by 4. You're still going to get a negative, but 12 divided by 4 is 3, and 8 divided by 4 is 2. So negative 3 over 2 is your slope. So let's go ahead and plug that in to your point slope form. Before we do that, let's make a decision. Let's use this first point for our point slope form. We only use one point once it's time to plug in. So we're going to ignore this. Let's go ahead. Y minus y1, which is 7, equals our slope of negative 3 over 2 times x minus x1 of negative 2. Take care of the double negative. This is now a positive. So we have y minus 7 equals negative 3 over 2x. So I'm starting to distribute already. And now the next thing I'm doing negative 3 over 2 times a positive 2. All right, let's work that out just in case if you don't know how to do it. Let's work it out. Negative 3 over 2 times 2, put it over 1 and multiply across. Negative 3 times 2 is a negative 6. 2 times 1, 2. Negative 6 divided by 2 is negative 3. All right, and we're back. So here we have a positive 3. I'm sorry, not a positive 3. It's going to be a negative 3. And negative times a positive is a negative. All right, last step. We're going to add 7 to both sides so that it's y equals, so it's y all by itself. So y equals negative 3 over 2x. Negative 3 plus 7 is a positive 4. So our final answer, y equals negative 3 over 2x plus 4. That's going to give us the final answer that we want here. Okay, let's keep moving. Okay, number 48. Which line represents the equation 2x plus 3y equals negative 6? The best thing to do when you're given an equation for a line and you're trying to match it to a graph is to put it in point slope form. We love point slope form. It's quick and easy to tell the slope and where it crosses the y-axis. So step 1, we're going to go ahead and we're going to convert this into point slope form. So I'm going to take 2x plus 3y equals negative 6. I'm going to subtract 2x from both sides. Now I have 3y equals negative 2x minus 6. And now I'm going to divide every term by 3 so I can get y by itself. So I have y equals negative 2 over 3 x, negative 6 divided by 3 is negative 2. So things I can tell right away. It has a negative 2/3 slope. So if I have a negative slope, I know that my line is going to go down like this. It should be going down. It has a negative slope. And it has a y-intercept, a b value of negative 2. So I'm going to look and make sure all the graphs cross the y-axis at negative 2. So here's the first one. That's negative 2. That's negative 2. This is negative 2. And this is negative 2. Okay, so they all cross at negative 2. Now let's try and see which of these have a negative 2/3 slope. Well, 2 answers right away I'm going to cross off. For B, this has a slope that's positive. So I'm not going to choose choice B. Same thing with choice D. My slope, again, is positive. So I'm not choosing choice D. Now I have to decide between choice A and choice C. So let's go ahead and focus in on our slope of negative 2/3. So negative 2/3 means that the rise, the vertical, is 2, and then the horizontal is 3. Since it's negative, it's going down. So I'm going to go ahead and really zoom in on these graphs and see which of these have a 2/3 slope. The way you would figure it out is you pick two good points. So I'm going to use the y-intercept, and then I'm going to use this point right here. And I'm going to count what's my rise and what's my run. So starting at the left point, I'm going to count down 1, 2 boxes, and then to the right, 1, 2, 3 boxes. So yes, my rise is 2, the vertical piece is 2, the horizontal piece is 3, and it's a negatively sloped line. So far, this one has the correct slope. Let's check our other choice, C. So again, I'm going to pick two good points. So I'm going to pick this point up here, and then the y-intercept. So let's take a look at the rise. I'm going to count down 1, 2, 3, and then I'm going to run to the right twice. So my slope has a rise of 3 and a run of 2, negative. Now, 3/2 negative is not what I want. I want a slope of negative 2/3. So that means my answer choice is choice A. Let's keep going. Number 49. What recursive function will allow you to solve for the nth term in the sequence? What recursive function? Okay, we're looking at recursive functions. All right, let's take a look at this list of numbers and see what's happening before we get started. Okay. So it's going from -3 to 1 to 3 to 5. So to get from -3 to -1, I'm increasing by 2. To get from -1 to +1, I'm increasing, I'm adding 2. To get from 1 to 3, again, I'm adding 2. And then 3 to 5, I'm adding 2. So this pattern is going to continue forever. I'm going to continue adding 2. This is something known as an arithmetic sequence. Okay, this is an arithmetic sequence. I'm going to write that down. Arithmetic sequence. An arithmetic sequence is when you have a pattern of numbers or a list of numbers, and the pattern is the same amount keeps getting added to get to the next number. Now, when they want a recursive function for an arithmetic sequence, it's always going to be in the same form. And the form is going to look like this. F of whatever n term you want equals the previous term. So we're going to talk about the previous term. And the way that we talk about the previous term is we say f of n minus 1. So the previous n value, not the current, plus whatever that common difference is, D. Whatever the common difference is. So common difference. So in this example, the only thing that we're going to have to plug in for is that common difference. That's all you ever have to plug in for if you're asked for a recursive function for an arithmetic sequence, something where there's just something being added each and every time. So our plus D is our positive 2. So we're looking for something that says f of n equals f of the previous n, or f of n minus 1, plus 2, which, in this list of numbers, is choice B. Notice we have a -3, which makes you think that you should start with the first term. That's not the case. For choice C, again, you have a -3, which makes you think you should do the first term. That's not the case. And then the last one, there's multiplication, there's the -3, there's a whole bunch of things that are not correct. So recursive function means you're going off of the previous term in the list and then adding the common difference. Choice B. Let's go on. Number 50. Bit of a word problem here. When Brandon went to the batting cages, it cost $2.95 per round, plus a one-time bat rental fee. Brandon played 6 rounds and paid $23. What is the cost to rent the bat? So this is our ask. We're finding the cost to rent the bat. Let's go back to the beginning. When Brandon went to the batting cages, okay, well, that doesn't really give us anything. It costs $2.95 per round. That word per means you're going to multiply the number of rounds by $2.95. So I'm going to get started. I'm going to write down $2.95, okay, per round, which is going to translate into 2.95. Let's use the letter. Let's use R for round. So 2.95 times the number of rounds plus a one-time bat rental fee. Okay, so now we're going to talk about some fee to rent the bat. All right, so plus the cost of the bat. And that will give you the total cost for the day. So $2.95 times the number of rounds plus the cost of renting the bat gives us the total cost. Now, Brandon played 6 rounds. So he played 6 rounds. So that means that R, the number of rounds, is equal to 6. And he paid $23. That's the total amount that he paid at the end of the day. So total cost here, the total cost was equal to $23. Let's plug all this information in because what we want to find is the value of B. So $2.95 times 6 rounds plus the cost of the bat is equal to $23. This is what we're going to go ahead and we're going to solve. We only have one variable, which is the cost of the bat, so we can go ahead and we can solve for B. Let's start by doing our multiplication. 295 times 6. So 2.95 times 6. 6 times 5 is 30. 6 times 9 is 54 plus 3, 57. 6 times 2 is 12 plus 5, just 17. Now remember, you put the point, the decimal, between the two sevens because there are 2 decimals to get from 5 all the way to the decimal, so we have to count the same amount here. All right, so $17.70. So I'm going to put that down, 17.70, or I didn't even have to put the 0, plus the cost of renting the bat equals 23. Now, we're going to subtract 17.7 from both sides, and we're going to be left with the cost of the bat. So a little bit more math here. 23.00 minus 17.70. 0. 7 subtract from 0. Let's borrow from the 3. So we have 3. Bring the decimal down. 7 subtract from 2. We have to borrow. 12 minus 7 is 5. And then 1 minus 1 is 0. So it's going to be $5.30 is the cost of renting the bat. So our answer is $5.30. So one more time, let's go over that. $2.95 per round. We refer to that as 2.95 times R, the number of rounds, plus the cost of renting the bat, which we called B. Together, it gives you the total cost. So once we have that R is equal to 6, and once we were told that the total cost is 23, we were left with only B as our variable, and we can go ahead and solve for B. All right, let's go on to the next problem. Number 51. Solve the system of equations. 2x plus 2y equals 28, while 8x minus 2y equals 22. There are 3 ways to solve a system of equations. graphing, which we rarely use, especially if it's bigger numbers. Substitution, where we solve for one variable and plug it in. And elimination. Right now, the way that this system of equations is written, it's ready to go ahead and use elimination. Now, the reason is, you notice here we have a positive 2y and a negative 2y. If I did positive 2y minus 2y, I'd get 0. It would eliminate the y value. So I'm going to use elimination here because I think it's going to make things a lot quicker. So to use elimination, if you have a positive and negative here with the same coefficient, they're going to end up canceling once you combine things vertically. So we're going to combine things vertically. 2x plus 8x is 10x. Positive 2y minus 2y, those are going to cancel. It's going to give you 0, so I don't even have to write it. Equals 28 plus 22. That gives you 50. That's a really simple problem now. 10x equals 50. So I'm going to divide both sides by 10 to get the value of x. So x equals, the zeros cancel, 5 divided by 1, just 5. So x is 5. Now I have the x value, I also want to find the y value. Once I have one of the variables, I can choose either of the two equations to plug in x and get the other value. I'm going to choose the top one because it has smaller values. So it's going to make solving a little easier. So I'm going to go ahead and I'm going to rewrite 2x plus 2y equals 28. And now I'm going to go ahead and I'm going to plug in x is 5. So 2 times 5 plus 2y equals 28. 2 times 5 is 10 plus 2y equals 28. Subtract 10 from both sides will give me 2y equals 18 once I've subtracted 10. And now last step, I divide both sides by 2. So I get y equals 18 divided by 2, which is 9. So my final answer, if I write it as a coordinate, is 5, 9. X is 5, y is 9. And that's using elimination as my method because all of the numbers were perfectly set up for elimination. Okay, let's move on to the next one. Number 52. Solve the system of equations. So now we have another system of equations. Now this one's a little bit different because neither the x's nor the y's are perfectly set up to use the elimination method. So now I have to make a choice. Do I use graphing, do I use elimination, or do I use substitution? Since I have a variable without a coefficient for both x and y, substitution is going to be an easy method to use. So I'm going to solve for one variable and I'm going to use it to plug into the other. So I'm going to convert x minus y equals negative 2 and solve for a single variable. And it's completely my choice. Do I want to solve for x and make it x equals, or do I want to solve for y and make it y equals? I'm going to go ahead, I'm going to solve for x. So I'm going to write down now x minus y equals negative 2. Solving for x, I'm going to move over the y value. I want to get x by itself, so I'm going to add y to both sides. So now I have x equals positive y minus 2. All right, so since I have the y value separate from the x value, I'm going to use it to plug into my second set of equations. So since I converted the first one, now I have to use the second one. I'm going to rewrite it. 7x plus 2y equals negative 5. And now I'm going to substitute out x with what I just figured out here, is that x is equal to y minus 2. So instead of writing x, I'm going to write y minus 2. So 7 times y minus 2 plus 2y equals negative 5. Since now I only have y as a variable, I can solve for y. So let's go ahead and do that. I'm going to go ahead and multiply 7 by both terms. 7y minus 14 plus 2y equals negative 5. Let's combine like terms. So we're going to have the 7y and the positive 2y. So we're going to have 9y minus 14 equals negative 5. Add 14 to both sides. Now we have 9y equals 9. Negative 5 plus 14 gives you 9. So now we're going to go ahead and we're going to divide both sides by 9. And y equals 1. Now that I have the y value, all I need to do is I need to plug in and get x. I can choose either one of the equations now that I know one of the variables to plug into. This looks like a much simpler equation, so I'm going to use that. So I'm going to go ahead and plug into x minus y equals negative 2. Since I know that y is 1, I'm going to plug in here. So x minus 1 equals negative 2. Add 1 to both sides. And now I have x equals negative 2 plus 1 is still negative 1. So my final answer is negative 1 for my x value, positive 1 for my y value. So I've used here something called substitution. This is the substitution method. Previously, I used the elimination method, where I added things vertically. Okay, let's get to the last question on this page. Number 53. Which of the following lines has the same slope as the line y equals negative 5/3 x plus 1? The slope of this line is negative 5/3. So we're going to look for the choice that has negative 5/3 as their slope. Notice that all of these lines, A, B, C, and D, are in standard form. They're not in slope-intercept form. So we're going to have to convert these into slope-intercept form before we know what their slope is. So let's start with A. 3x plus 5y equals 10. We're going to subtract 3x from both sides. So we're going to have 5y equals negative 3x plus 10. Then we're going to divide every term by 5. So that we have y equals negative 3 over 5x plus 2. Negative 3 over 5 is the slope of this line, not negative 5 over 3. So nope to choice A. Let's go on to choice B. I'm going to rewrite it again. 3x minus 5y equals 20. And let's go ahead. So subtract 3x from both sides. I'm not even going to write it because we know how to do this already. Subtract 3x from both sides. You have negative 5y equals negative 3x plus 20. Divide everything by negative 5. So now we have y equals negative 3 divided by a negative 5. The negatives cancel. So it's just a positive 3 over 5x. Positive and negative make a negative. 20 divided by 5 is 4. So 3/5 x minus 4. 3/5 is your slope. So it's not choice B. Let's try out choice C. 5x plus 3y equals 21. Subtract 5x. So now we have 3y equals negative 5x plus 21. Divide out the 3. And now we have y equals negative 5 over 3x plus 7. And here we have a slope of negative 5 over 3, which is what we wanted in the question. We wanted to find the line that had a slope of negative 5 over 3. So we're going to go ahead and we're going to select choice C. The last one is choice D. Let's just check it. Make sure it's also not correct. 5x minus 3y equals 27. Subtract 5x. So we have negative 3y equals negative 5x plus 27. Divide every term by negative 3. These cancel. So y equals negative 5 over negative 3. That becomes positive. So 5 over 3x minus, because I have a plus and a minus, 27 divided by 3 is 9. 5/3 positive is the slope of the last one, so it's not choice D. Choice C is the only correct answer that has a slope of negative 5/3, but we had to convert it into slope-intercept form first. Okay, we have one more page to go.